Voltage control in smart grid. Voltage control is crucial for maintaining voltage levels within acceptable limits to ensure proper functioning of electrical equipment and prevent damage to the power system. In traditional power systems, voltage control is primarily achieved through automatic voltage regulators, AVRs, installed at substations. In REGS, voltage control becomes more complex due to the decentralized and intermittent nature of renewable sources. Some methods for voltage control in REGS are: A. Reactive power control. REGS can contribute to voltage control by adjusting reactive power output. Wind turbines and solar inverters can be equipped with control mechanisms to regulate reactive power flow. B. Volt-var control. Utilizing volt-var control strategies can help regulate voltage levels by adjusting the reactive power output of renewable sources based on the voltage measurements at various points in the grid. C. Coordinated control. Integrating voltage control algorithms with load frequency control and energy storage management can provide a more comprehensive and efficient control approach. D. Smart inverters. The use of smart inverters in solar PV systems can enable advanced voltage control capabilities by allowing real-time communication and control. To achieve effective load frequency and voltage control in power systems with a high penetration of renewable energy, a combination of these methods, along with advanced control and communication technologies, is often necessary. Proper planning, coordination, and integration of renewable energy sources are vital for maintaining the stability and reliability of the grid. Load frequency control, LFC. In REGS, load frequency control becomes more challenging due to the intermittent nature of renewable sources. Solar and wind power generation depends on weather conditions, and their output fluctuates. Various methods are employed. A. Energy storage systems. Integrating energy storage systems like batteries can help store excess energy during high generation periods and supply it during low generation periods, stabilizing the grid frequency. B. Advanced control algorithms. Implementing advanced control algorithms that predict renewable energy availability and demand can enable more proactive load frequency control. C. Demand response. Implementing demand response mechanisms can incentivize consumers to adjust their electricity consumption during peak and off-peak periods, helping to balance the load.